Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Not Even X, and it's by Nurgle's Gift. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box here. We have cells connected by an X must sum to 10, and all X's are given. So that means the negative constraint is in play here. So, for example, if this were a 3, we would know this is a 7 because these two digits add up to 7. Or, sorry, add up to 10. Excuse me. If this were the 3, we would know that the digits that share an edge with it are not 7 because they would have to have an X in between them if they were, right? So, because we know all X's are given, none of these are X's, therefore this cannot add up to 10. So if this were a 3, this would not be 7 for any of these cells. If this were a 6, none of these cells would be 4, correspondingly. So remember that negative constraint there. We have cells connected by a black dot must be in a 1-to-2 ratio. One double the other. And there is no negative constraint there, so we don't have to worry about that. We have, so this cells connected by a black dot must be in a 2-to-1 ratio. If this were 2, this would have to be a 1 or 4 to maintain that 1-to-2 ratio. We have cells with a gray circle must be odd, so all of these cells are odd. And the cells with a gray square must be even, so this must be even here. And finally, we have no 2x2 set of cells can add up to an even number. For this rule only, cells with a gray circle or square have their parity reversed. That is, add 1 to its value. That's interesting. So in every 2x2 set of cells in the grid, none of them can ever add up to an even number, right? So you can't have like 4 even numbers here. You can't have 4 odd numbers here. However, for a gray circle and for a gray square, they actually add 1 to their value, quote unquote. So this is actually, in the square, it has to be an odd circle. But value-wise, it's essentially considered an even value. That's interesting. Huh. I don't think I've ever run into that rule set before. I've never run into the 2x2 rule set where no 2x2 set of cells can add up to an even number. That just means you can't have an even number of even and odd digits in that 2x2 space. You have to either have one considered odd number, or 3 odd numbers in every 2x2 space. Oh, that's interesting. That's essentially what it means, right? So in no 2x2 area, in every 2x2 area, you have to have either one considered odd number or 3 odd numbers, right? Because if you have 0, 2, or 4 even numbers, 0, 2, or 4 odd numbers, that means you are guaranteed an even number for the 2x2 area. Yeah. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. What does that mean? So these, they're considered even for the set of, that's going to be weird. Let's mark them as odd anyways right now. This is even. So this must be an even cell. Okay, that's interesting. Well, anyways, this is a 1-to-2 ratio with another digit. So this must, since this is odd, this has to be 2 times that digit. Because the odd digit can never be 2 times another digit. So this is even, which forces this to be even. That means the rest of the box must be odd because we have 4 evens already here. This is 1 or 3. 1 or 3 is in a 1 to 2 ratio. Right. 1 and 3 are in a 1 to 2 ratio with 2 and 6 specifically. So then this is 4, 8. We don't know what these are. And this satisfies the odd and evenness because we have one, this is considered even, and this is considered odd. So they're just essentially swapped. So there's 1 odd in this set. This is 3 odds here. This is 3 odds here. This is 1 odd here. So one of these 2 digits must... Okay, so this is considered even. So since this is even, and these 2 are even, this must be an odd digit here. So we have 1 odd here. Can this ever be 2 evens? If this were 2 evens, you would have 2 other evens at most in the box. I guess this could be 2 evens. So these are all the same parity as each other, right? So whatever parity this is, this has to be the opposite. And it's in a 1 to 2 well, with the same digit, potentially. Actually, it is exactly the same digit. It's in a 1 to 2 ratio with the same digit, guaranteed. That means these are opposite parities. So these cannot be opposite parities. These have to be the same parities, which means these are both even. So these are both even. We have 4 evens in row 8, which eliminates evens in the rest of the row. These are both odd then. We have 1 and 1 here. This can't... Okay, this is considered even also. Right? Because if this is even... The odd are a different parity, so this is considered an even parity. So it's 2 evens. We need a third even because we cannot have 2 odds. So this must be even here. One of these is even, therefore in box 8 we have 4 evens already. Therefore this is odd. And that satisfies this because this is considered even, these are considered even, this must be odd. Because we have 3 evens in that 2 by 2 area. This is considered even in even, because again, the circle is reverse parity. Therefore, this must be even. So this is, we have 2 evens here. We have 2 odds here and 1 even. Therefore, this must be odd. This is even and odd. But this is an odd digit, which makes that an even, so this must be even, and this must be even, and therefore this must be even. We have 4 evens in box 9, so this must be odd. Not even, odd. We have 3 evens here, therefore this must be odd. These are the same parity, so that's fine. This is considered even. These are different parities, so one of them's even, one's odd. If you have an odd here, that would be 2 odds, which is not allowed, so this must be even. Therefore, since this is even, we have 2 evens already in row 6. That would, if this were even, that would force 5 evens in row 6, which is not allowed. So the yellows must be odd, and the orange must be even. So these are 1, 3 again. to be in a 1 to 2 ratio with another digit. So this is 2 and 6 again. This must be 4 with 2 or 8. We're not sure which, because they're both even. Therefore, this can never be 4. It's 2, 6, or 8, which makes this 2, 4, 8 here. We don't know what this is. These are both odd or both even. We don't know which. It could be either. These are both the same parity. These are both the same parity. This must be a different parity than this one, though. So we'll mark this orange and this pink. These must be different parities, right? Because if they're the same parity, then we have two odds at least, and that would make this either 2 evens, which make 2 even 2 odds, or 4 odds, which makes an even number. So this has to be pink. These are different parities. These are the same parities. So these must be different parities also. Since this must be different parities, we don't really have a restriction there. These must be different parities. So this is 1 blue and 1 red. We have 4 blues now in row 6. So that eliminates blue in the rest of the column. So this is red. Therefore, you have 2 reds here. This is blue, so this cannot be blue. This must be red. Since this is red, this can't be red. This is blue. Here we have, in this 2x2 area, it's not adding up to an even. This 2x2 area, it's not adding up to an even. So these must be the same parity, right? Because if there were different parities, we'd have 2 evens and 2 odds guaranteed, which is not allowed. So these are both even then, because one of them must be even. If they're both the same parity, they must both be even. Therefore, this is 2, 4, 8, 4 being one of these digits here. This cannot be 2, 8. It cannot be 4, 6. So these cannot be even. This has to be odd parity, which means this is even parity. This is odd parity. In this 2x2 area, we need another odd to make an odd digit. So that's an odd. And this can't be the same parity as this because we have 1 odd. So this must be even. That gives us 4 evens in the row. So this must be odd here. This is considered even again. So this is even, even. We need another even here. Even, even, even. That would force us to be odd. And that satisfies there. So this is a 1, 3, 7, 9 pair, triplet. This then, both of these must be even. Because this cannot be 1, 3, 7, or 9. 5 cannot be next to an X because they would have to have a 5 on the other side. And you'd have a duplicate repeat in the row. So therefore, these are 2 evens. These must be different parities. We're not sure which is which. This can no longer be 2 even digits. If this is 2 even digits, we have 5 even digits in column 3. So this is both odds, which forces this to be even because we now have 5 odds in column 3 then. One of these must be odd, and the other must be even for this 2x2 area to not add up to an oh, wait, this is considered... No, that's not true. This is considered even. This is considered even. This is considered odd. So they must be the same parity, where you can't have 2 odd ones here, because then that would eliminate 1, 9, and 3, 7 as possibilities here, and that would no longer be odd. So one of them has to be at least even here. Since one of them is at least even, they both must be even. So these are both even here. For this 2x2 area to work, because this is considered even, this is considered odd. These must both be the same parity, because otherwise they would have 2 and 2 of each. In column 2, we already have 4 blues, so the rest of the column must be odd. So these are both odd. That means this is a 1379 quadruplet, which eliminates 1379 in the rest of the box. So this must be even, because 5 has to be here. So this is 5 and odd. This is obviously 1 or 3. This can't be 1 or 3. It's 7 or 9. That means this must be a 4 here. So this is 2, 4, and 8. We have a 2, 4, 8 triplet, which eliminates 2, 4, and 8 from the rest of the column. This can't be 2, 4, 8. This has to be 6. This can't actually be 4. So this must be a 4 here. That means this can't be 4 and 6. So this is a 2, 8 pair. 2, 8 eliminates 2, 8 in the rest of the box. So this is 6. This is 4. This must be 6 and 3 in a 1 to 2 ratio. Therefore, this cannot be 3 or 7. This is a 1, 9 pair. This 1, 9 pair eliminates 1 and 9 in the rest of the box, so this is 3 and 7, which forces this to be a 6 to be in a 1 to 2 ratio with 3 or 8. This then must be a 2 or 8. This is 2 or 8. This cannot be a 2, 8 pair because of the 2, 8. That would eliminate all possibilities for that cell. So this is 4 or 6. This can't be 4 and 6, so this must be 2 and 8. The only one that's in a 1 to 2 ratio with an odd digit is 2. So this is 2, this is 8, that makes this 2, that makes that 8. This is 4 as the remaining even digit. 2 is in a 1 to 2 ratio with 1 here. This must be a 4, 6 pair. This is 2 or 8 then. This 2 eliminates 2 here, so this is 6. 6 is in a 1 to 2 ratio with 3, so this is 3, this is 7. This cannot be a 3, 7 pair. It's a 1, 9 pair. 4 eliminates 4 here. So this is 6, and that's 4. That makes this a 6, and the rest of box 6 has to be odd digits. One of these is odd, one of these is even. We're not sure which. This is 2 or 8. Six has to be one of these two. These must be the same parity. So these are different parities. These are obviously the same parity. That's fine. This is in a 1 to 2 ratio. It cannot be 3 and 6. It can't be 4, 8. So this is 2 with 1 or 4. So 2 is one of these two. We know that for certain. 7 cannot be here. One of these is 4. It's 2, 8 pair. 2, 8, 2, 8. This cannot be a 2, 8 pair. So it could be 4 and 6, but this can't be 4 and that can't be 6. It can't be 3, 7, so it could also be 1, 9. So those are the possibilities. Four here eliminates 4 here, so this is 6, this is 4. We have a 6 in one of these two spots, and it cannot be here. So this is odd, which forces this to be the 6 and even. That means where is the 6 in? We actually have, yeah, we have 8 6s. We know where the last 6 has to be. It has to be here. So this is 6, this is 4. These are both even. 4 cannot be here or here, so this must be a 2, 4 pair. That makes these both even. That makes this not even because we have 4 evens in column 9. Let's see. This is considered even, so that's fine. So this is even, even. This must be 1 odd and 1 even. Therefore, this can't be odd. Sorry, this can't be even because we already have an even in the column and then 3 other ones. So this must be odd. This is 3 digits anyways. These two are even. This is odd. This has to be even then. Therefore, this can't be 2 evens. These are 2 odds. That's fine. Okay, these are 2 evens. This must be an odd and even. In the box, then, we have 4 evens accounted for, so these are both odd. This is 2 or 8. We have a 2, 8, 2, 8 pair in column 6, which eliminates 2 and 8 in the rest of the column. So this is the 4. This cannot be 4 here. One of these is even, one of these is odd to make sure this 2 by 2 area doesn't add up to an even number. So this must be odd here, which forces this to be even here. So this must be an 8 because that's the only even digit left. This 8 eliminates 8 here, so that's 2, which makes this 8, which makes this 2. So this is a 4-8 pair. This 2 eliminates 2 here, so this is 8, which makes this 2, which makes this not 2. This is 4, this is 2. That means this 4 eliminates 4 here, so this is 8, this is 4. So one of these is an 8. This has 2 odds. It must have another odd with it to make sure this doesn't add up to an even digit. So this is odd, this is even, and therefore this is an 8, which eliminates 8 here. So it's 2, 8, 2, and 8. This cannot be a 1-9 pair because that would eliminate all possibilities here. So this is 3, 7, and this can't be a 3. So this is 7, this is 3. This can't be even because we have 4 evens in the column already. So this is even, and this is a 2. Okay, and we just fill in the rest of the digits. We have the negative constraint. So if this were 1 or 9, it would guarantee that it has to be with 1 and 9 with one of the other ones and would have to have an x. So this cannot be 1, 9. This is 5. That means these are 1, 9. We have a 1, 9, 1, 9 pair in row 2, which eliminates 1 and 9 in the rest of the row. So this is 7. 3 cannot be here. 3 is one of these, so this is 3, 1, or 9. And this is 5, 1, or 9 here. This can't be 1 because of the 1 in the column. We have 1, 5, and 9 in the rest of row 6. But if this were a 5, this can't be 1 because of the 1 in the column. If this were a 5, that would force this to be a 1-9 pair, which would guarantee that an x would have to be in between them. So this cannot be 5. This has to be 9, which makes this 5. That means this can't be 5. None of these could be 9. In column 7, we still have a 3 left, so this is 3. And then 5 and 7 remaining. And this can't be 7 because otherwise there would be an x next to it. So therefore this is 5, this is 7. The remaining digits in box 7 are a 1, 7 pair. This has to be a 5. The remaining digits in row 4 then are 3 and 9. Okay. This can't be 3 because of 3 in the column, so this is 9, which makes this 3. The remaining digits in column 1 are 1, 7, and 9. Again, if this can't be 1. If this were a 9, that would guarantee it would be next to a 1 without an x in between, which is not allowed. So this is 7, this can't be 7, this can't be 7. What digits are left over? This must be a 5. This 5 eliminates 5 here, so that's 1. This is 5. We are near the 1, 9 pair. Yeah, but anyways. Remaining digits here. Remaining digits in column 5 has to be a 5 because of the 1, 9 pair. This is 1 or 9. We have 1, 7, or 9 remaining in column 4, but this can't be 1 or 7 because of 1 or 7 in the row. So this is 9, which makes this 1, which makes that 7. This 1 eliminates 1 here, so that's 9 and 1. That makes this a 7 too, because that's the only remaining digit. This is a 9 as the only remaining digit. The 7 eliminates 7 here. So this is 1 and 7. This 9 eliminates 9 here, so it's 1 and 9, which forces this to be 1. That makes that a 9. This 1 eliminates 1 here, so it's 9, 1, 9. This can't be 9 or 1, so this is 3. This can't be 3 or 9. This is 1. We celebrate the 3 in the corner because we know we're getting close to solving it. This is a 3, and this is a 5. And that's how you solve it. Yeah, very nice use of the no 2x2 set of cells can add up to an even number. That was very cool, actually. A very nice use of parity. to restrict things, and it fit very well with the odd and evenness of the first the circles and squares, but also the X's, right? So pretty cool. Pretty cool. Nice little setup. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.